So there's this huge battle happening in AI right now. And you know what? It's not about who has the biggest, baddest model. Nope. It's about something way more fundamental. The plug. It's a war over how AI agents connect and talk to each other. And to figure out who's going to win, well, we need to take a little trip back in time.
It's kind of funny, isn't it? To really get a handle on the future of these incredibly complex AI systems, we have to go back, way back, to the 1980s, right at the dawn of the personal computer. A time when a war was fought not over chips or memory, but over something as basic as a connector.
So let's set the scene. We're in an era of total technological chaos. The problem in the 80s was not that we didn't have cool computers or disk drives. We did. The problem was that none of them could talk to each other. It was a war over the simple act of connection.
Yeah, in the early 80s, the PC market was, well, it was a complete mess. Imagine this. You go out, you buy a brand new hard drive, but it will only work with one specific brand of controller card. You had all these competing, totally incompatible standards with these wild names like ST506 and ESDI, and it just meant nothing was interchangeable. This chaos was absolutely strangling innovation.
I mean, really think about that. Every single device was its own little isolated island. This vendor lock-in basically trapped you inside one company's little world. You couldn't just go out and buy the fastest drive and mix it with the best controller. No way. They wouldn't work together. Progress was just crawling along because everything was stuck behind these walls.
But then, something shifted. A revolution started to bubble up. A solution came along that wasn't just a new gadget, but a whole new way of thinking. An open, universal standard that was about to change computing forever.
And this is where we meet the hero of our story. Its name was SCSI. The idea, which came from Shogart Associates, it was brilliant because it was so simple. They created a common language, a universal plug, basically, that any drive and any controller could use to talk. It separated them, which meant companies could innovate on drives and controllers all on their own. And this idea? Well, it eventually became the famous SCSI standard that pretty much ran computing for decades.
And the impact? Oh, it was absolutely explosive. All of a sudden, the whole game changed. Companies couldn't just rely on trapping you anymore. They had to compete by actually, making the best stuff. This one single standard created this incredible, vibrant market where the real value wasn't just in one little piece of hardware, but in the power of the entire interconnected ecosystem. Okay, so why the big history lesson, right? What does any of this have to do with AI? Because right now, today, the world of AI agents is standing at the exact same crossroads. We're facing the exact same choice. Are we going to build a bunch of closed-off islands, or are we going to build an open, interconnected continent?
It really all boils down to two completely different ways of thinking. On one side, you've got closed systems. This is where developers manually wire agents together in a fixed workflow. It's efficient, for sure, but it's super rigid. And on the other side, you've got open systems, where agents can find and talk to each other on the fly over a shared network or a bus.
All right, so on one side, you have something like OpenAI's AgentKit. The best way to think about this is like you're literally drawing a flowchart. If you want a translator agent to talk to a summarizer agent, you have to hard code that specific connection. The summarizer can't just look around the network and find a translator. It has to know its exact address, its specific ID. It's just like those old drives on a fixed cable. It's great for one specific setup, but it's not flexible at all.
But then you flip the coin, and you've got Google's A2A protocol. And this is the open bus we've been talking about. It's designed from the ground up to be the SCSI bus for agents. Here, an agent can just shout into the network, "Hey, I'm a summarizer." Then, any other agent, maybe one built by a totally different developer, can just search for summarization and connect to it automatically. This means you can build applications by snapping together the best agents from anyone, anywhere. It's a game changer.
And this, right here, this brings us to what is probably the single most important idea that separates these two worlds: discovery. The ability for agents to find each other on their own in real time, that is the absolute keystone of an open ecosystem. It's everything. So how does it actually work? Well, it's kind of like a simple four-step dance. First, an agent puts up a little digital business card. They call it an agent card that says what it's good at. Second, another agent that needs help just searches the network for a skill, like summarization. Third, the network points it to the best agent for the job. And fourth, boom, they connect and get to work. It's dynamic, it's on demand, and it lets agents find each other without anyone having to pre-wire anything.
Okay, and this is the moment where it all just clicks into place. The analogy, it's not just close, it's almost perfect. That old disk controller, that's today's agent orchestrator, the thing routing all the commands. The disk drive itself, that's just a single agent doing one specialized job. The SCSI bus, that's the A-to-A protocol. And the most important part, that old SCSI inquiry command that let a controller ask a drive, hey, what are you? That is the exact same idea as a modern agent card. History isn't just rhyming here, it's practically a carbon copy.
And, to really complete the picture for today, we have tools like the Reactive Agent Hub. If A to A is the bus itself, the wires connecting everything, then the RAH is like the powerful motherboard that everything plugs into. It manages the whole ecosystem, deploying agents when they're needed and keeping everything organized. It's the thing that turns a simple communication standard into a truly living, intelligent network.
All right, so let's pull back for a second. Let's zoom out. Because this isn't just some nerdy technical debate. The choice between these two architectures, it's a choice between building standalone applications and building entire open ecosystems.
And if you look at this table, it really just lays it all out, doesn't it? A2A is all about dynamic discovery and global reuse. It's a system designed for building a whole industry. AgentKit gives you these tight, controlled connections, which are honestly perfect for embedding AI deep inside a single app. So it's not really about which one is better, it's about what are you trying to build, a product or a platform that everyone else can build on top of.
And this quote, man, it just hits the nail on the head. History shows us this over and over and over again. While closed systems can be incredibly effective and they can help you hit specific goals really fast, it's the open protocols that end up building entire industries and unlocking these massive waves of innovation.
So that leaves us with the big question. As we build this next generation of intelligence, this new world, are we going to do it with closed walls and siloed gardens? Or are we going to build an open, collaborative bus where any agent can connect, discover, and create with any other? The choice we make today is going to define the next 40 years, just like it did back in the 80s.